Hi students, welcome to YourPedia education. So welcome to the NPTEL questions module. As we already started the NPTEL questions module in different subjects, let us start a new subject, that is network analysis. So what is the advantages of NPTEL questions module, and that too with YourPedia education, is we are offering the NPTEL assignment question solutions along with the PDF solutions as well as video solutions, and we are providing a book for each and every department. This is for electrical engineering book, and in this one around 3000 plus questions, 3000 to 4000 plus questions will be there, which will be useful for your practice, in different competitive exams like GATE, IIS and any state PSU exam. So what is the use of NPTEL questions is, this assignment questions will be prepared by IIT professors. So this will be there will be a chance you may get a relevant questions in your GATE exam also. So this is the reason, this is the most important module for your all competitive exams along with the GATE and IES preparation. Now in this session we are going to start the new subject of NPTEL questions module in our electrical and electronics and as well as instrumentation background students. So network analysis, which is the new subject, which will be common for all the electrical electronics and electronics engineering, electronics and telecommunication engineering and in instrumentation engineering students. This will be common. Now let's start the question, which was in network theory, network analysis. The question number is 20. So most of the students will do the wrong in this question, because they know only about the energy storage in the capacitor, but they don't know the how much amount of energy is dissipated in the resistor in this circuit. Now let's read the question and let's understand the question, and then we'll solve this question by using general methods, and then we'll go with the when we will substitute the values which was given in the question. Now what is the question? The 10 microfarad capacitor was initially uncharged. What is the meaning of initially uncharged? There is no initial energy storage in the capacitor. So voltage across the initial voltage across the capacitor is 0, I can say. Next, and when the which K is closed, the capacitor gets charged to 5 volts eventually. What is the meaning of eventually? Means as the time progresses to over a long time periods, the capacitor will reach to 5 volts. Means as time t tends to infinity, the voltage across the capacitor is 5 volts. That is the meaning of that statement. How much amount of energy in millijoules is dissipated through the 100 ohms resistance? That is the 100 ohms resistance. How much amount of energy is dissipating through this 100 ohms resistance during the charging process of your capacitor? So during the charging of your capacitor to 5 volts, how much amount of energy will be dissipated through the capacitor, through the resistor, not capacitor. Energy will be stored by the capacitor, dissipated by the resistor. So in this circuit, most of the students will know the capacitor, energy stored in the capacitor, that is how much of value, half CV square is the capacitor stored energy, half into what is the capacitor value? It is 10 milli into what is the voltage across the capacitor? It is 5 square. So 125 millijoules is the capacitor energy storage in the capacitor. But he is not asking this energy stored in the capacitor, and he is not asking the energy stored in the capacitor. He is asking us to calculate the energy dissipated in the resistor. So to answer this question, so how we will calculate the energy through a resistor? It is I square RT. If you know the time period, you will get you can substitute the time period. Otherwise, how you will calculate the energy dissipated through a resistor? By using general formula, integral 0 to infinity, because time is unknown. So what is the energy dissipated through the resistor? It is I square R, that is power, and will integrate with respect to dt. So first we need to calculate the current expression of your resistor. then use the given expression, use the obtained expression in the integration, then substitute integrate the given function and substitute the limits, then you will get the final amount of energy dissipated through the resistor. Now, how you will calculate the current through this capacitor? Current through the capacitor during the charging period. So to get that value, what is the current through the capacitor? Because current through the resistor is equal to current through the capacitor. So if you know the current through the capacitor, it will be equal to current through the resistor. So what is the current through the capacitor equation? It is C into voltage across the capacitor, like this. I'm solving the question with the generalized principles, generalized notations. Then I'll substitute at last I'll substitute the given values in that expression. So do we know the value of voltage expression of your capacitor? No. So what is the voltage expression of your capacitor? Voltage expression of your capacitor, if you remember, it will be well and good. Otherwise, use the general principle of your capacitor. So capacitor initial infinity final voltage plus initial voltage minus final voltage, initial voltage minus final voltage into e power minus t by tau, e power minus t by tau. What is tau? Tau is the time constant, which is equal to RC. Tau is the time constant, which is equal to RC. So what is the meaning of Vc of infinity or Vc of 0? Means voltage across the capacitor as time tends to infinity, voltage across the capacitor as time tends to 0. So this is the meaning of these values, initial value and final value. Whenever time tends to infinite, how much amount of voltage that exists across the capacitor? Because as time tends to infinity, I'll take the circuit again. So this is the capacitor RC circuit, and here you have a source. Let me take this as V. So this is R, this is C. So here we close the switch and time tends to infinity we have taken. So as the time tends to infinity, this implies frequency tends to 0. So when frequency tends to 0, how much amount of reactance it is offering? 1 by omega c. As frequency is 0, so your reactance offered by this capacitor is infinity. So it acts as an open circuit. Otherwise, it acts as an open circuit, or otherwise there won't be any current flow in the circuit. So your capacitor charges to a source voltage value, then there won't be any current flow through the resistor. So what is the voltage across the capacitor you will get under final conditions? It will be same as your supply voltage. So the voltage across the capacitor at a infinite time period is equal to your supply voltage. Yes sir. Otherwise, you just use the XC principle. It is 1 by omega c. So as omega is equal to 0, so you will get infinite ohms. So whenever you have open circuit, what is the voltage across the open circuit? It is 5 volts. Simply. Yes sir. If this part is open circuited, no current will flow through the resistor. So final voltage will be V only. That is also possible answer. So this is the final value. What about the initial value of the voltage? Initial value means if you take the initial time period, that is t tends to infinity 0. So what is the meaning of t tends to 0? It is f tends to infinity. F tends to infinity means what happens to the XC? It will become 1 by omega c. So as omega tends to infinity, what happens? This value becomes 0 ohms. So a capacitor acts as a short circuit. What is the voltage across the capacitor during this period? Vc of 0. How much it is? 0 volts. Now let's substitute these two values in the final expression. What is the final expression of your capacitor voltage? How much amount of voltage will be there across the capacitor? Let me take new pages. Now, what is the final voltage across the capacitor? The final expression of your capacitor voltage is equal to Vc of infinity Vc of infinity final plus initial minus final into e power minus t by tau. So tau is RC. Let's substitute all the values. This value is V plus what is the initial voltage? 0 minus what is the final voltage? V into e power minus t by RC. E power minus t by RC. So what is the final capacitor voltage expression? It is equal to V into 1 minus e power minus t by RC. E power minus t by RC. This is the expression. What is the capacitor current? IC of t, that is IR of t, resistance current, which is equal to capacitor current. It is C into dVc of t by dt. So if you differentiate this expression, what you will get? Differentiation of constant is 0 minus differentiation of this one e power minus t by RC. E power minus t is e power minus at is e power minus at into minus a. You will get what is the minus a here? Minus 1 by RC you will get. So what is this value? C gets cancelled. So finally what is the expression you will get? The capacitor or resistor current IR of t, which is equal to how much? How much? It is V by R into e power minus t by RC. Now we got the value of current. What I'll do is I'll take this current as some I naught first, some current, some I. I'll take this as current I. Later I'll substitute. So what is the resistor current here now? So the value of current, resistor current IR of t is equal to how much? I into e power minus t by RC. Now what is the energy dissipated in the resistor? Which is equal to integral 0 to infinity IR square into R dt. So let's substitute these values: 0, infinity, I into e power minus t by RC whole square into dt. So what you will get? I square into R, here you have R, right? So integration of 0 to infinity e power minus 2t by RC into dt. So what is the integration of this e power minus 2t by RC? It is I square R into integration of e power minus 2t by RC is e power minus 2t by RC by minus 2t minus 2 by RC, minus 2 by RC. Yes or not? So this is about the expression. Okay, plus some constant k, So this is the value of voltage, current. Now I square R into so this is RC you got by 2, you have e power minus 2t by RC plus k. So this is the final energy storage in the resistor. So what is the initial energy stored by the resistor? It will be 0. So 0 you will get this value as 0. This value as 0. Now, so what is this value you will get? So this value is R square you will get. This value becomes R square into C into C into C. So what is I actually? 1 by 2. What is I actually? If you take the previous slide, I is equal to V by R. I is equal to V by R. So V by R square into R square into C into R square into C. So if you substitute the limits here, 0 and infinity, so what you will get? Here you have minus. So if you substitute the integration limits, finally you will get the expression like this. So let me first substitute the limits. So e power infinity is 0, minus of minus e power 0 is 1. So you'll get finally the energy stored, energy dissipated in the resistor as I square by 2 into R square C. This is what you will get. Now what is the I value? I value is V by R whole square into 1 by 2 into R square into C. So if you observe this value, this R square gets cancelled. So finally the energy dissipated in the resistor is equal to half C V square we got. Half C V square we got. Now if you take the circuit into consideration, so this is the K which is closed at 0, Now this is the supply V, this is R, this is C. Now tell me how much amount of energy is stored by the capacitor? Energy stored by the capacitor is half CV square. What is the energy dissipated by the resistor? Energy dissipated by the resistor is how much? This is also another half CV square I can write. Now how much amount of energy is supplied by the source? Energy supplied by the source is CV square. Now what is the efficiency of energy transfer for capacitor? Efficiency of energy for capacitor is output energy to the input energy, it will be 50%. So this circuit, RC circuit, is operating at 50% of efficiency, 50% efficiency only. So this is the additional content of the questionnaire. And what is the answer for this question is same as ER is equal to EC, which is equal to 125 millijoules. So millijoules is already given in the question. So answer for this question is 125 is the right answer. So what is the additional data which is obtained by this circuit is the efficiency of the circuit. The efficiency offered by this circuit is how much? Efficiency offered by this circuit is how much? 50% only. So this is how you need to solve these kind of questions. This is one of the most important and very, very good question in interview point of view, because in BARC interview one student got this question and he was asked to prove that the energy transfer or the efficiency of this RC circuit is 50%. So this is how you need to prove. Okay, so we'll conclude this question. Okay, thank you, all the best.